Very good. So here we have the last question, right? From the
Yes, sir.
dynamics worksheet. So can you read this question, please?
Okay, sir.
Yeah.
Number 3, figure 3.1 shows an astronaut in space near the space station and in orbit above the Earth.
Yes. So it's above the Earth, right? So it's a matter of thing to consider that above the Earth and he's in space.
Yes.
Okay, then continue.
The total mass of the astronaut and all his equipment is 160 kilograms. The astronaut is initially at rest related to the space station, but he is then pulled towards the space station by a rope. The acceleration towards the space station is 0.35 meter per second squared for 1.2 seconds. A calculate, number 1, the resultant force that causes a mass of 160 kilograms to accelerate at 0.35 meters per second squared.
So what's the answer?
The resultant force.
Yeah.
It's 56 newtons, right?
Yes, yes. Then
Let me write the answer down.
yeah.
Number 2, the speed at which the astronaut is traveling after 1.2 seconds.
So how will get it?
This one I will. Wait, I see.
So this one you got in kinematics.
Yes, I will multiply the time with the acceleration.
And what should be the formula?
V equals to U plus AP.
Yes, and U is 0, right?
Yes.
Because the astronaut is initially at rest.
Yes. So it will be the acceleration into time.
Yes. And the answer is?
Like 0.42 meter per second.
0.42 meter per second.
Yes.
Okay. So continue next.
Excuse me, sir. I'm facing some trouble with the audio quality. Can I disconnect the audio and then reconnect it?
Yeah, sure, sure.
Sir. Sir, I'm back.
Yeah. Okay, continue.
The resultant force on the astronaut is constant for 1.2 seconds, but then it decelerates 0 instantly as the rope becomes slack. On figure 3.2, sketch the speed time graph of the astronaut for the first 3.0 seconds of his motion.
Yeah. So you got here after 1.2 seconds, the speed 0.42.
Yes.
So if it is 0.42, that means you have to label it in the sketch, in the graph. You have to label the speed and time. The time is 1.2, that one you have to label. Then the speed 0.42, that one you have to label. And as there is no specific, scaling given here, that's why you can take it anywhere. Like if we consider here, it is 0.42. Okay, so level it here 0.42. This is our final speed, right?
Yes.
Then we have here the scaling of time 1 to 2 seconds. So 1.2 means 1/5, right? 1/5
Yes.
of this space you can take. So mm, so we can go 1.2. So after 1.2, it is 0.42. So we can reach here, right? It is our time, right?
Yes.
So till here we have uh, acceleration, right?
Yes.
So
It is
here,
constant.
yeah, and it's constant. Yeah, constant acceleration. So we give here steeper straight line, right?
Yes, sir. And then there will be
Yeah.
curve for deceleration.
Then what they're saying, and they are saying uh, the resultant force on the astronaut is constant for 1.2 seconds. That means if resultant force is constant, then acceleration is also constant. But
Yes.
then it decreases to zero
The
instantly.
acceleration is zero.
uh, but then it decreases to zero. That means the acceleration and the resultant force is zero. So acceleration is zero, right?
Yes.
As the rope becomes slack. So if it is in space, right? So
Yes.
in space, we are not having any external force working. So the speed already it has, it will go with that constant speed, right? In,
Yes.
in a, straight line motion. So we are having here constant speed. It's slack here. So we are having here constant speed uh, and 3 seconds, till 3 seconds, right? You
Yes.
continue it. Okay. Horizontal line parallel to time axis, it will go for 3 seconds. Is it clear?
Yes, sir.
Okay. So is done, right? The worksheet is done.
Yes, sir.
Okay. So we are now done with topic 3, dynamics. We are actually planning to have a new topic, huh? New
Okay,
topic,
sir.
that is mass, weight, density. That one we are going to do. And in school also we will do that, huh? So we
Okay, sir.
continue that way. We continue that way. And in our next term, final term, we will try to, uh, you know, uh, com- make our syllabus compatible with the new syllabus for 2023, the candidates, okay?
Okay, sir.
That one. So let's start with mass weight density. Is a very, very easy topic. Uh, Only few things we are going to learn from there. And also many of the things, I think almost everything you know before, nothing is there new. Just we have to, you know, check out or the relate the ideas we have with kinematics and dynamics with the mass weight density. Some of the aspects we will correlate. Okay, That is
Sir.
the thing. Otherwise, the things we are going to discuss, you know it before in class 7,
Yes, sir.
like measuring density, the formula you know. Then you also know uh, the how to measure the density of uh,
To measure the volume of a liquid or solid. H. Describe how to determine the density of a liquid, of a regularly shaped solid, and of an irregularly shaped solid with sinks in water at volume by displacement. I. Define density and recall the use of the formula. Density is equal to mass divided by volume.
so if you look at the learning outcomes, you see that most of the things are familiar with you, right?
Yes.
I only see that this one, only learning outcome B is new for you. That is inertia, right? Defining mass
Yes.
in terms of inertia. That one. Then other things you know, right? Weight formula, you know, mass
Yes.
into gravitational field extent. Mm. So, and this one, you know, density formula. Then how to measure the
Yes.
density of irregular shaped object, regular shaped object. You know. So, in the first definition of mass, you know, here is inertia. Huh? Can you
Yes, sir.
read please from inertia?
Yes, sir. Inertia. Inertia is a property of a mass which resists change from a state of rest or motion. The inertia of an object refers to the reluctance of the object to start moving if it is stationary in the first instance, or the reluctance of the object to stop moving if it is moving in the first instance. When a body of matter is stationary, it needs a force to make it start moving. The bigger the mass, the bigger the force needed. We say that masses have inertia, a reluctance to start moving.
So the examples I gave you, they are saying the same thing here, right?
Yes, sir.
Whatever I discussed about the inertia thing. So here we got a little bit idea about inertia. Now we are defining mass. Huh? So
Okay.
mass, uh, before going to mass, we have here amount of substance. Huh? Can you read please here?
Okay. Matter is a material substance that constitutes the observable universe and, together with energy, forms the basis of all objective phenomena. The basic building blocks of matter are atoms. The atoms themselves comprise of nucleus and electrons.
Okay. So mass, like you have, if you are taking one block of iron, huh, and you are taking in other way around, you are taking a block of wool or block of cotton. Huh? So if you measure them, you will get uh, same mass, right? Both of them 1 kg.
Yes.
But in one case, the volume is very small. Another place, the volume is very big. However, the mass is same. Why it is same? Because the amount of matter in the block of iron, those are tightly packed, right?
Yes.
But in cotton, those are not tightly packed. Though those are staying a little bit far apart. That's why they have the same mass even after they having the different volumes. So the mass is here depending on the amount of matters or amount of substance present in the object, isn't it?
Yes.
Whatever the volume is, whatever the size is, or whatever the shape is, that's not the main thing. The main thing is how much amount of substance is present in that object, and on on the amount of substance, the mass is depending, right? So
Yes.
Clear to you, right? Now
Yes.
we have the definition of mass now. Here you see the mass of a body of matter is quantitative measure of its inertia, that is its resistance to a change in the state of rest or motion of the body when a force is applied. SI unit of mass is kilogram. It's a scalar quantity. The greater the mass of a body, the smaller the rate of change in motion. Hmm.
Yes,
Although
sir.
mass is defined in terms of inertia, it is conventionally interpreted as the mass of a body of matter is a measure of its amount of substance. So we are having here both the definitions, right? So
Yes, sir.
what you'll write, you will write it first. Huh? This one you write first. Then you write or, huh? Or after writing or, then you write also this definition. Okay,
Okay, sir.
do it, huh? Please.
Sir.
Hmm.
Excuse me, sir.
Yes, yes. Please tell me.
Did you get the assignment?
Yes, I got it. I got it.
I sent 2 emails.
I got your emails. I saw them. I'll give
Take
reply.
the last one, please.
Hmm. Tomorrow or day after tomorrow, I'll give the reply altogether. So, are you done with the writing, mass?
Yes, sir. Almost. 1 minute. So I've written it.
Okay, very good. So you wrote this definition and this one also, right? This definition you wrote.
Yes.
Then after this you write SI unit of mass is kg, and this much you write. Ah,
Okay, sir.
then you write
I've written it.
mass. Yeah, mass is measured by using,
Okay, sir.
yeah, beam balance or electronic balance. This one you write.
So I've written it.
Yeah, very good. Now uh, is I'm giving you sometimes some homework here. We have now 15 minutes. So this 15
Yes, sir.
minutes, you just, I think you, if you go through, you'll understand most of the things, and you go through till the last of the notes.
Okay,
So
sir.
it's already uploaded in our D class, and it's very small notice.
Yes, I saw it.
Yeah, so you go through all these things, and if you have any queries, in our next class at the beginning, we will discuss the queries, then we will straight go to the worksheet. Okay? Okay,
Okay,
today
sir.
this much. Thank you so much.
Okay, sir.
Allah
Welcome,
Hafiz.
sir.
Salam.
Okay, sir.